All right, on to objective two of our seventh additional focus area, focusing today on speed and velocity, the differences between the two. So let's get into it. Speed, I mean, you know the definition really. It's just you always say like how fast something moves, but when we really are saying is the distance something moves divided by the time. In other words, if you hear somebody can run a 4-3-40, that means they can run 4.3 seconds. And this is really fast. They can run 40 meters. And if you do the division, that's almost 10 meters per second, which means in 1 second they can run about 30 feet. Again, these are super fast people, but some people are able to do that. Velocity, a lot of people just say velocity and speed are the same thing. They're how fast something goes, which is almost true, but velocity includes direction, kind of like displacement does. So an example would be a car traveled 50 miles per hour on the way home. Well, that just tells you the speed, 50 miles every hour. If I said the same sentence but added one word, east, of car traveled 50 miles per hour east on the way home, now that's describing the velocity because velocity includes direction. Look at the picture down here. Both of these cars are going 25 meters per second. However, this car has a velocity of negative 25 because it's going to the left, and this car has a velocity of positive 25 because it's going further right. So again, speed and velocity basically the same, how fast something's going, distance divided by time, except velocity includes direction. So what kind of problems could you see on the content assessment? You might see a math one, something as what is the speed of an object that travels 15 meters in 3 seconds? Well, remember, the formula speed is distance. Our distance is 15 divided by time. Our time is 3 seconds, and 15 divided by 3 would give us 5 meters per second. What about this one? This is a little tougher because this is a velocity problem. An object moves backwards from where it starts, 100 meters, and it takes 20 seconds. Well, the formula is the same, but since it's velocity, we need a direction now. How do we know the direction? Backwards means negative. So this 100 is really negative since it's backwards. So now I plug it into the same formula. Distance divided by time. Distance, negative 100. Time, 20 seconds. And when you divide negative 100 by 20, your velocity would be negative 5 meters per second. In other words, you're going back 5 meters every second, backwards. What if we talk about vectors like we did in the fifth focus area, the forces, fields, and forces focus area? Well, got tongue-tied there. Remember, our vector review, vectors tell us two things: the strength of the force and the direction. Direction is super easy. Whatever way the arrow points is the direction of the force. I just drew 3 different directions. The strength of the vector, or how strong the force is length. So forget those 3. Boom, I just drew one vector, and I drew another in the same direction. But what I do know is this first vector or this first force is stronger because it's longer. That's all you need. Longer arrows mean stronger vector or force. So the picture says, what's the difference between these two vectors? Well, they're going the same direction because the arrow points the same one, but this vector is going faster or has more force. And since we're talking about speed, in this case, we can say it has more speed or velocity. What's the difference between these velocity vectors? Well, we know it's velocity. Which one has more velocity? Well, it's the same because the arrows are the same length. These pictures are the same size. So what's different? Well, they're going opposite directions. This top one would have a positive direction, and this would be a negative direction. Or we might say east and west if we knew the arrangement. All right, on your own, try to answer this question. So press pause before, but what you're trying to do is tell me the highest speed from A, B, C, D, E vector all the way to the lowest. So press pause and do that in your head, and I'll give you the answer here. All right, here is our answer. So the highest speed, what they're really saying, the biggest arrow. So D has the biggest arrow. Who cares what direction? They didn't ask anything about that. The second longest arrow would be the second fastest. So that would be this one. And then this is the next biggest, and then this, and then last but not least, this little arrow over here. So it's super easy. When they give you vectors, it's like, what's the fastest or slowest? Well, the fastest is the biggest arrow. The slowest is the smallest arrow. Last thing we're going to talk about is some information we can get when we look at position versus time graphs. See, position here is on the y-axis and time here on the x. So when we have a position time graph, like you will in the content assessment possibly, what does it tell us? Well, easily the vertical or the y-axis, it'll tell you, it says position. The x-axis tells us time, but that's not enough. What it does is lets us know, based on the slope, how fast or what the velocity of the object is. And what do I mean by that? All right, let's look at between 0 and 3. How fast did this, whatever it is, it doesn't tell us, how fast did this object move? Well, we have to take the slope. Remember, change in y over change in x. So at 3, we had a position of 4. And at 0, we were 0. So our change in y was 4. 4 minus 0. Our change in x, well, we said we started at 0 and we went to 3. So our change in x is 3 minus 0. So our answer for our velocity would be 4 over 3, or 1 1/3 if you wanted to convert that out. But 4 over 3 meters per second would be our velocity because we looked at our slope. Don't worry, you're not going to really need this to solve the math of it. What you do need to know is if you have a line that's straight up almost versus a line like the second line, this line, since it's steeper, means it's going faster. Its position is changing quicker than this one, so it's moving faster. If your slope is going down, like this side, we can see the hill's going down. That means you're slowing down. You're decelerating. You're slowing down. And that's kind of what you get by the curve as well. So again, if we say from this point here at 1 second to 5 seconds, our speed is slowing down. But from 7 to 10, we end up going upwards. So that would be speeding up. Let's look at those as far as how they might look on the test. 2 swimmers competed in a race. This graph shows how the position of both swimmers changed over time during the race. At what rate of speed did swimmer 1 travel? Now, swimmer 1 is this person right here. And all we need to do is take any 2 points for distance. So let's just say, I'm going to do different ones than are over here. You can look at this on your own, pause it if you want. But I'm going to take the top here for my 100 distance. And I'm going to take the bottom here. So remember, change in y. My y was 100 meters minus 0, which is just 100. So I'll leave it at that. And at the time that was 100, my x was 50. And it started at 0, so that's 50 for a difference. 100 divided by 50 is 2 meters per second is the speed. Now look over here. We picked different spots. I picked 40 seconds and 20 seconds. But when I looked at the distances, it was 80 over 40. 80 over 40 is still 2 meters per second. So it really doesn't matter which points you pick if you have a straight line. If you have a curvy line, it would matter.